Hey guys, Travis Gillespie, and the idea of we've been talking about intercepts, but the idea of a slope, and we're going to call slope here, we're going to call it M. So the idea is looking at slope as the rate of change, and that's a sloppy M, so let me fix it up. So it's the rate of change, and you can look at that a bit informally as, hey, it's the rise over the run, or a little bit less informally, more formal as the rate of change in the y, that dependent variable, over the rate of change in the x, which is the independent variable. You could actually be real precise in writing down a formula to compute the slope. I'm going to call this y sub 2 minus y sub 1. And remember, to actually find the slope, you need 2 points over x sub 2 minus x sub 1. And a reminder, to compute the slope, you at least need 2 points. Therefore, x1, y1 for the first point, and x2, y2 for the second point. Let's see if I can change some colors, add some color to our life here. We have x1, y1, again, x2, y2 for our second point. And in the long run, you could actually find out the slope by looking at the change in the y's over the change in the x's. And I'm just going to change that y color, that subtraction, to say, hey, this is the difference. And why do we use M, you might ask? Well, to be honest, I don't know. If I find more out about it, I'll let you know. But for now, just think of it as a convention. It's conventional to use. So typically M stands for the slope. So the slope is, I subtract the two y values I have and also subtract the two x values I have. And that change of the y's over the change over the x. So here's an important point I want to bring across. You're always subtracting the y1 by the, or I guess the y2 by the y1. And let me erase that real quick. I'm getting ahead of myself. You're always subtracting y2 by y1 and the x2 by the x1. So, hey, my first ordered pair I'm dealing with is x sub 1, comma, y sub 1. And then the second, I'm just trying to keep color-coded here. The x sub, the y x sub 2, comma, y sub 2. Cool. So hopefully I'm not getting ahead of myself. But you want to keep this order and not mix them. Let me explain further. So sometimes people make the mistake and they actually switch these, and that's what you don't want to do. And I got to erase that mark I just made. So we're going to look at the points 5, comma, -3 and -1, comma, 2. And actually look at what I'm talking about. Well, looking at these points, you say, hey, what do you actually do? Well, let's see if I can keep color coding, but what you'd say first is, hey, take 2 and subtract, because I'm looking at y2, and what do I actually do? Just pick one. So say 2, cool, and minus -3 for y1. We'll put that over. Oh, well, he had 2, so we have x1 here. That was, or x2 here because you had y2 here. So now you're dealing with negative 1, negative 1, and minus O for our x1. So x1 here is going to be 5. That's a positive 5. I'm going to erase that. It's a bit sloppy. And you can actually check to see if this makes sense. I'm just going to say m right here equals, well, yeah, you can check to see if this makes sense by saying, hey, negative 1, 2 should actually be one of the points. And if you look up here, sure, negative 1 comma 2 is one of the points. And then again, 5, negative 3 should be another point. Well, 5, negative 3 is my second point. So yeah, that actually makes sense. Cool. And let's change colors just to stay color coded here. Cool. So that's my m equals my change in the y over the change in the x. Cool. So what do you actually get? Well, you actually combine over here, and let's change colors again. Um, in order to subtract these opposites, you actually end up adding, so negative minus a negative is a positive or plus. So you will say, hey, 2 plus 3 is 5. That is so sloppy. Again, sloppy. There we go. So 5 over, let's restart this one real quick. 5 over negative 1 minus 5. Or in other terms, you could say, hey, I have negative 1. I'm going to take away 5, so I end up with negative 6 here. So the slope of this is negative 5/6. Hey, and from here, you know what? I'm going to make a common mistake and just change this up a little bit to show you something that a lot of people do. So I'm going to take, hey, let's reuse these ordered pairs again. And those ordered pairs, I'm just going to write them out again. So our ordered pairs here that we were dealing with were 5, negative 3, and the other was negative 1, comma 2. Cool. So the mistake that's typically made here, well, starting out, just like before, I'm going to say, hey, let's take 2 and actually subtract negative 3. So that part is actually the same, but the mistake, where you'll see the mistake that's actually made, is in the subtracting in the x. And a student ends up typically saying, well, so I've taken 2, subtracted negative 3, so now I'm going to go to 5, make that a little bit cleaner, go to 5, and actually subtract from here negative 1. So here's the mistake right here. And if you look at this, 5 comma 2, that's not a point that's up here. You don't see 5 comma 2. And in fact, you don't see negative 1 comma negative 3. These are not ordered pairs from the list. And you actually end up getting a different answer. So 2 plus 3 is, and you end up getting 5/6, it looks like. So yeah, you actually find out, hey, this is incorrect. It's done wrong or incorrectly. And I urge you, because it's important, that you subtract, well, 1y from its y, and then second, 1x from its corresponding x values. Cool stuff. Hey, good luck, guys.